Okay, move to a different part of the room and see if that helps. And if not, like start it over again. Okay, that's not really a different. Go to the back or something. All right. So remember when we first learned sine squared x plus cosine squared x equals 1? Then what we did was we started manipulating that. We started like, let's subtract cosine squared x from both sides. Do you guys remember doing this at all one day in class a long time ago? Okay. So really, do you have to memorize every single one of them? Probably not, but I would definitely have this one memorized because this one is where all those other ones come from. And really, I am not great about remembering the ones with tangent and secant, and I like forget what is minus and what's plus in those. So I usually use this one for the most part. So, I mean, if you want to memorize them, if you're good at memorizing stuff, you might as well memorize them all. Are there other questions about section 5.1? Oh, maybe I should mention, if you didn't see it yet, there's going to be a quiz on section 5.1 next class. It will not be on 5.2, which we are learning today, but 5.2 will definitely help you with 5.1. But there will be a quiz next class on 5.1. So now, are there any questions on 5.1? Anything you want to go over? Okay, so I opened 5.2 notes already. So 5.2 is just building off of 5.1. I'm going to look at just a couple of vocabulary words right here. 5.2, did it work? Sanjay, did it work? Okay. So 5.2, the conditional equation might be something that you haven't really used vocabulary-wise before. Conditional equation is an equation that is true for only some values in the domain. For example, sine x equals 0 is a conditional equation because it only works for values of pi as long as those values of pi are multiplied by an integer. For example, sine x equals 0 at when x is negative pi, 0, pi, 2 pi, 3 pi, etc. So that's a conditional equation because there's only certain numbers in the domain that work for that equation. When you find these values, you are solving the equation. We are not solving equations today. So what we are going to be dealing with is identities. An equation that is true for all real numbers in the domain of the variable is called an identity. It's true for all real numbers in the domain of that variable. It's called an identity. And this is an identity that we were using before. Sine squared x is equal to 1 minus cosine squared x. That's true for all real numbers of x. Doesn't matter what we plug into x, this will always be true. So we would never be solving this. You can't solve it. It's just exactly the same on both sides. So those are called identities. And that's what we're going to be dealing with today is identities. What we're going to really be doing is we're going to do almost like proofs. Did I get you excited by saying that word, proofs? So they're different than geometry proofs, but they're different and similar. So I will tell you I hated geometry proofs. Could possibly be because I was absent 32 days that year, but I just never got them, so I hated them. But I actually like the trigonometric identity proofs. They're kind of like solving little puzzles. So if you like puzzle solving, this might appeal to you. There's 5 different things that you want to think about while doing this, and then we'll do a bunch of examples of them. So number 1, we're only going to work on one side of the equation at a time. So and I put this right here, follow the correct form. Just like when you do geometry proofs, like there's a specific form that you need to follow. You don't get to make up your own thing. So we're going to work with only one side of the equation at a time. It's better to work with the more complicated side first. When it says it's better, that just means it's easier. So not that it's better, but that it's easier to work with the more complicated side first. And even though it doesn't seem like it, addition or subtraction is more complicated than multiplication. Number 2, we're going to look for opportunities where we can factor, where we can maybe find a common denominator, and where we can substitute fundamental identities. Number 3, we're going to pay attention to the other side, the side we're not working with, to always be thinking about what we need to get to. It's going to give us clues about what to do on the side that we are working with. If you are stuck, try turning everything into sines and cosines. All of these identities that we have, you can turn back into sines and cosines. Even tangent. What's an identity of tangent that turns into sines and cosines? Sine x over cosine x, right? So we could turn everything back into sines and cosines if we need to. Now, number 5 is super, super, super important. Number 5 is always try something. Even if you try something and it doesn't get you all the way to the answer, you're picking up ideas and you're learning things along the way that are going to help you somewhere else. If you come to me, and as much as I want to tell you the answer, if you come to me with a blank page and say, I don't know what to do, then I'm going to say, I'm not going to help you. Okay? Because you have to try something first. There's always something you can try. Now, this is what's so crazy. This is crazy. If you do try something and it is wrong, here, I'll use this example that we're about to do anyway. If you try something and it was wrong, blah, 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 da, 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 I have a bunch of wrong stuff there. You just click this like erase. It's so cool. And it gets rid of it for you. It's okay that I put the wrong stuff down because now I just can get rid of it. Oh, is anybody working on paper? Because they make those for paper too at the end of your pencil. Or you could, I know this was crazy. Let's say I worked a whole page and it was wrong somewhere. You don't even have to erase it. You can just do this through it and then move on. But at least you're trying something. Even trying it wrong is going to help you either learn what not to do, or it might give you a clue of what actually to do, or it might help you on a different problem. You have to try something. None of this is going to magically ooze into your head and you're going to know what to do. It all comes from experience. I can do these really fast because I've experienced and I've taught it. Okay? You're going to need that experience. So how do we do these? Let's go to example 1. To verify a trigonometric identity, you will pick one side that you are not going to do anything to. You're going to work on what I suggest, the more complicated side. So which side should we stay the same up here? The right side, I hope that's what you were all saying, sine squared. So I'm just going to box it in. This box is not required, but I like to box it in because then I remember, okay, this is my final answer that my left side has to say when I'm done. Now I'm going to look at my left side and I'm going to look for ways to change that into sine squared. And it might not pop up immediately. So instead, when I see things like secant squared, when they're squared, I might start thinking about those Pythagorean identities. From section 5.1, that's where all the identities are listed for you. But I'm not going to pull those out. I want, for the most part, to try to do them without. I mean, I have a little bit more experience, so I remember them better. You definitely can have those. But I want to try to do things that you remember. Okay, and then here's the last thing before we get started. There could be 10 people in here that do it completely different, but all get the right answer. There isn't always one way to do these. And because of that, I'm going to be hand grading assessments on this stuff. There's no way we can do like a Canvas quiz on this stuff. Okay. The quiz on Thursday is a Canvas quiz because that's just simplify it and you type in your answer. But these, you have to show your steps. That is your answer, is showing your steps. So I'm going to have to hand grade these. Okay. Now, because I told you I'm not going to help you, it's all about you getting experience. I'm going to call on people and you guys are going to give me ideas, and you might have a different idea than the person I called on. Your choice is to go with your idea and see if you can get there, or your choice is to follow along with the class even though it wasn't your idea. Okay? So does anybody see any sort of identity that I could play around with, something that I could do to make this simplify? Just anything that you see I could try. Lainey, what are you thinking?
Secant squared theta minus 1 is tangent squared theta.
Okay. Do you have that memorized? Do you have it open? Oh, okay. What were you going to say?
Square into secant squared theta over secant squared theta minus 1 over secant squared theta.
Okay, so I'm going to put both of those up there. They're different. They're way different. But I think both of them are important to look at. So let's see. Lainey said tangent squared theta over secant squared theta. And then, actually, let me do it this way. So what you do to have the correct form is we want to show what side we're working on and only stay on that side. So I'm working in a column. I'm not working in a row. I'm working in a column. I'm lining up my equal signs. So because we've got two different ways we're doing this, I'll just make a separate column on the other side. I'm just going to do one at a time, but I definitely want to go through both ways. So let me just write the other idea over here, and then we'll just finish out Lainey's first before we go on to the other one. So if you didn't hear what Christopher said, he said to basically distribute that denominator, multiply everything by 1 over secant squared. So we've got secant squared theta over secant squared theta minus 1 over secant squared theta. Okay, now I'm going to leave the blue one alone for a little bit. I'm going to work on the red one. We'll come back to the blue one. Both of those are completely different starting points. They're both okay. All right, so if you're doing the red one, what could be another step that we could do? What could be a next step? Who could volunteer? And by the way, I want everybody participating at some point today. So if you don't volunteer now, you're just going to get called on later. Yay. Madeline, try something.
So tangents like y over x and secants y over x.
Okay, so don't use y over x. Use, instead of y, use sine. Instead of x, use cosine.
Sine over cosine.
Okay, so you're saying tangent is sine squared, tangent squared x is sine squared, or sorry, theta over cosine squared theta divided by 1 over cosine squared theta. So from our notes previously, we already had used tangent with sine over cosine, and we've already used secant as 1 over cosine. Those showed up in our notes a couple times so far, so that's totally fine. Who's talking? How did you get there? So you're doing, instead of dividing by a number, we're multiplying by its reciprocal. And I can't write as fast as I talk, so. So we're going to multiply by the reciprocal of the denominator. See how I have to show like these steps? So if I'm multiplying those, then I can cancel my cosines. Oops, didn't mean to change color though. Is that what I was trying to get? Oh, that is what I was trying to get. So then I can stop because I got there. So we're manipulating the left side to make it look like the right side. So now we're going to do the exact same thing, but we're doing it with a different starting point. So with this one, if I started a different starting point, same question, different starting point. What could I do from secant squared theta over secant squared theta? Barry, it's 1. Can I change 1 over secant squared theta? To what? Cosine squared theta? Okay. Just a reminder, we don't have earbuds in, even if your music is off. We don't have them in during class. Thank you. Okay, so from here, 1 minus cosine squared theta is one of those Pythagorean identities. Who knows what it equals? Eden? Say it again. Sine squared theta. So whose way was better? That's not there isn't an answer to that. There isn't an answer. It's whose way is better. It just depends which way you thought of and which way you went through. I think one of them took less steps, but once you're like halfway through doing it one way, you don't want to like start over just to do less steps. You've already written it that far. Might as well just finish it. So questions? Okay, let's look at the next one. So now we are combining fractions before using identities. So that might give you a hint that I am going to box that guy in. I'm going to work with the side with the fractions and combining fractions. Do you have a question or you want to say something? Then don't say anything yet. Sorry. Okay. What is your question? Okay, I can come back to it. All right, you guys, please, I'm not calling on a person for this because you should all be able to answer this question. How do you subtract fractions? Common denominator, thank you. That's how you do anything with addition or subtraction in math. You have to have like terms. And like terms is common denominator. That was so nice of you. You might get quarantined now because you went near somebody. Just kidding. Just kidding. I know, that's why I said just kidding. Okay. All right, so this is where some people will struggle, and I'm sure it won't be you all, but some people will struggle because they don't have very good foundational backgrounds in factors. We have to find the lowest common denominator, and to do that, you need to say, how do I factor 1 minus sine alpha? I mean, I can, but that's not really going to help me. How can I factor 1 plus sine alpha? Or can I factor? Okay. Other than 1 in itself, these are not factorable. And because they're not factorable, that means that they do not have any factors in common. So to find a common denominator, what do we need to do? We need to multiply by each other, right? So like my next step, I'm going to be showing you how I am multiplying the first fraction by 1 plus sine alpha over 1 plus sine alpha. This is not a place where you get to shorthand everything. These are proofs. You do have to write out your work. Oh my gosh. And if there is anybody in here and you know who you are, if I cannot read your writing, you got to learn how to start typing this stuff. Okay. If you're using Kami, on Kami, they do have equation tools which might help. Like, there's that alpha right there. They've got a squared somewhere. I don't know where it is. It's on here. Oh, it's probably the caret. I haven't played around a lot with this Cami stuff, but if you are typing things to me, I better be able to follow it because that's how I have to grade it. I have to grade it by hand. Means I have to understand what you are communicating to me. Okay. I'm sorry, I'm slow. And 1 minus sine alpha, 1 minus sine alpha. Okay, so when we multiply the 1, obviously nothing changes, but when we multiply the denominator, equal sign. When I multiply the denominator, do you guys know what 1 minus sine alpha times 1 plus sine alpha gives you? 1 minus sine squared. Yep. Alpha. So I didn't want to show all the steps for that. I just put it off as like, we should already know this stuff. So I have 1 plus sine alpha over 1 minus sine squared alpha plus 1 minus sine alpha over 1 minus sine squared alpha. And so I'm going to add the numerators. And then I'm going to collect like terms. Sometimes when I just start going into like autopilot, I'm like, find common denominator, add together, and I'm just like, do. Sometimes I forget what I was originally doing. So I would definitely encourage you at some point where you just realized you were in autopilot to maybe go back up and be like, what am I trying to solve for again? Oh yeah, 2 cosecant squared alpha. Oh yeah. And then I'm going to tell you, guess what? That's not what we're solving for. Because Criswell typed it in wrong last night when she was typing in the dark and couldn't see. Yeah, it was my fault. Sorry, use your whiteout. The original question is wrong. It should be secant, yeah. That's what it says in the book, and then I just copied it wrong when I typed it, and then I noticed it first bell, and I said, oh, I got to change that by this bell, and then I forgot to change it. Sorry about that, because it's not going to work otherwise. You guys get this? I had a mistake on small writing, old lady, couldn't see, dimly lit room. All right. Now we are trying to get to secant. Where could I go from here? Who's going to volunteer this? I got the 2 already. Who's going to volunteer the information? Yes, Megan. Right. 1 minus sine squared alpha is the same as cosine squared alpha using that Pythagorean identity. So we'll go ahead and switch that out using the Pythagorean identity. And then from here, I'm just going to do the last step. 1 over cosine squared alpha is the same thing as secant squared alpha. So I bring it up to the top and change it to the reciprocal. And then it matches. Okay, let's look at the next one. All right, so we're going to look up here and we're going to decide which one is the more complicated side, because that's the side I'm actually going to work with. Which one's more complicated? The left side, so I should box in the right. That does not mean you can't do it from the right side. Just might be a lot harder sometimes. You want to challenge yourself? Try it from the easier side, which will be the harder way. All right, looking for ideas. I'm not going to do this for you. You guys have to come up with ideas. And some of you have talked and some of you haven't. And they're just going to get harder, so. Ryan, come on. Give me something. Okay. Sam, are you following along with what Ryan did? What did you try first? That's okay. I told you you didn't have to.
Tangent squared x plus 1, I did that as instead of,
Wait, you did it as what? I couldn't hear what you said. You did it as, what did he say?
yeah,
Oh, secant? Probably. Is it right? Is it secant? Okay. That's fine too. So that's a different way.
and then I did the
Right.
cosine x minus 1. For negative sign.
I can't understand what you're saying, Sam.
I did the cosine squared x plus 1 was negative sine squared x.
Oh, you changed that one too. That would be the second step. I'll just leave that alone for a second. Okay. So if we go with Ryan's way, what could we do next? Foil? Okay. Okay, so when I multiply my first term, what's going to happen to my cosines? Okay, so we're going to get sine squared x. And then we do my outer, we're going to get minus sine squared x over cosine squared x. Then we do our inner, we're going to get plus cosine square x. And we do our last, we get minus 1. I can't believe how nicely, I did not try this one this way ever. And this one actually works out pretty good. Sorry. Oh, I don't know why I put a 0 there. Sorry. Just out of habit, I think. So if we're going off of Ryan's original, the pink one, if we're going off of that one, Philip, is there something that you see that I could do now? The pink one, yep. Mm-hmm. That's what we're trying to get, isn't it? Aren't we trying to get minus tangent squared x? Almost wrote a 0 again. Sorry. This is what we're trying to get right here. I'm going to box it in, but I'm going to erase it. That's what we're trying to get. Emily, do you see something? Okay. This thing keeps like taking forever to save, and then it keeps getting stuck. So she said this is negative sine squared x, right? And then we get negative tangent squared x. Oops. Good. That's not even actually what I was looking at when I said, ooh, that one works out perfectly. I was looking at a different way too. I was looking at these adding up to equal 1 and then subtract 1 from there. That's another way we could do it. There's like all kinds of different ways. So that way works. And then Sam started doing it this way, which some of you might have started doing it this way as well. Cosine squared. Oh, you said that was negative sine. Is that what you said, Sam? Okay. And then secant would be 1 over cosine squared x multiplied by negative sine squared x. Oops, I put the equal sign on the wrong side. And then that would equal negative tangent squared x as well. So you guys see how like we can have an answer key that has completely different work, but both answers could be right. So you have to be really good about communicating with me if you're not sure if your way works. I don't mind spending time to look at it. Okay. As long as I have time, I don't mind.
Do we have to show every single step?
Every step that is important for figuring out how you got from here to here. Like,
So for like the if you were gonna change from the tangent
pink or blue, pink or blue.
blue.
Okay.
If you're gonna do tangent squared x plus 1 to secant and
Oh, do these have to be separate?
But yeah.
No. I just told him to hold on because I just want to do little part at a time, but you could do those in one step for sure. Yeah. Yep.
Do we also need to write out 3 on blue, or can we just skip to 4?
You could skip to 4 for that one. Now, could you skip from 2 to 5? No. You're just missing too many steps there. Okay. And if that's your question, that would be a good question to ask me on homework too. Like, do I have enough steps? The rule of thumb is if you're not sure, just put the step down. Okay. If you have too many, oh well. All right. The next one is just converting sines, cosines. Like if you have absolutely no idea what to do to start, you can just convert everything to sines and cosines. And I actually feel like that's what we did with the pink one with Ryan's, because I called on him because I could tell he was thinking, but I didn't know what he was thinking. So he converted tangent to sines and cosines, and we worked with it that way. So that's kind of what this example is like, only a different example. Which side should we work with? Left or right? The left has the plus sign, so it's more complicated, which means it'll actually be easier to work with. So I will box in the right. Now convert everything to sines and cosines. Tangent would be sine x over cosine x. Cotangent is going to be cosine x over sine x. And before even going there, I'll just tell you, because I have experience with this stuff, I know I cannot add together tangent and cotangent. They're different terms. I can't add them together. So what I might usually do is always try to make fractions, because I can add fractions together by having a common denominator. I can't add just 2 whole numbers together when they aren't like terms. So I might just do this anyway. Or I might keep them cotangent or tangent or something and do it that way too. But okay, so we need common denominator. So I'm going to have sine squared x over sine x cosine x. Do you see how I didn't write the step where I was actually writing what I multiplied by? That would be okay. Then I get oh my gosh, this thing is working so slow today. Cosine squared x over sine x cosine x. And when I have a common denominator, I can just add my numerators. Sine squared x plus cosine squared x over sine x cosine x. And I check out what I'm supposed to get anyway. What should I do? Who's got my next step? You helped already. I want to make sure everybody gets to help. You guys have helped already. Have you helped, Gracie?
I don't remember.
Okay, Gracie. I don't remember either. Okay, numerator equals 1. That's Pythagorean identity. All right, I'm totally running out of space. I didn't write small enough, so I'm just going to do this. There you go. All right, I just copied it so I didn't lose my space. There we are. All right, I need another volunteer. Gavin. So do you want me to write this? Okay. That's what I would prefer to do, to not write that step. So a better way to explain that might be 1 over sine x is equal to cosecant x, right? And 1 over cosine x is equal to secant x. And I just have it out of order. So secant x, cosecant x. There we go. And why am I allowed to switch the order in which I multiply? Some property called the, starts with a C. Commutative, yeah. Wondering if we remembered that. All right, this next step is not verifying an identity. It's just showing you what it means to rationalize a denominator. It's just reviewing something from a previous course. Remember when we rationalize, we use the conjugate of the denominator. You did this with radicals a bunch. So the conjugate would be the exact same binomial with a different sign in between. If you multiply them together, the conjugates, they would be a difference of perfect squares. So on top, I would have 1 minus cosine x. On the bottom, I would have 1 minus cosine squared x, which would give me 1 minus cosine x over somebody volunteer, so that can be your turn. I have no idea. Sorry about that. It's 1 plus cosine x on top. I just wrote it wrong. Jack. Yes. Now, we aren't verifying anything right now. I was just showing you what happens when you multiply by the conjugate. We end up getting it into a form that allows us to do the Pythagorean identity. So if we need to do something, we maybe need to manipulate it by multiplying by the conjugate. That might be something we try at some point. All right, so let's try it on this one. So if I'm going to multiply by the conjugate, hopefully you guys know that I'm going to box in this side. I'm multiplying by the conjugate. So I'm going to multiply the conjugate. I'm going to have cosine y over 1 minus sine y multiplied by 1 plus sine y over 1 plus sine y. So when I multiply by the conjugate, or just a lot of times when I multiply, I'm thinking ahead, and I don't know if I want to distribute this or not. So typically I won't distribute it unless I know I need to. Since they're different, they're cosine and sine, they're different ratios, I'm not going to distribute it just in case I want them separate later. All right, on the bottom, I get 1 minus sine squared theta. All right, I'd like to hear from Tyler or Peyton or Vivian or Kyle or Sanj. Yes, Peyton.
The denominator can be cosine squared y.
Okay. Change that denominator using the Pythagorean identity. Who else hasn't talked? Patrick, I haven't heard from. Abigail, I don't think I've heard from you. Ava, you did? Okay. I'm starting to forget now. I think that might be it. Just people that I listed: Tyler, Vivian, Kyle, Sanjay, Abigail, Patrick. It's a hard one. So here's the thing. You got to try something. So out of the 5 or 6 of you that I just said, somebody try something. Who's going to try it? You try something on your own. Sanjay, what do you think? You can cancel one of the cosines. And you're allowed to do that because cosine y is factored out. You're allowed to do that because cosine y is factored out. You don't know what I'm saying? Let me give you a time where you could not do it. And then please don't write down this. But I'll show you where you can't cancel it out. Please don't write this down though, because I don't want you to have it written down and think later that's what you're supposed to do. This would be a bad thing, what I'm about to do here. Well, if it works. Okay, I'm going to do this to prove a point, but every time I do this, a bunny dies. When you cancel that you haven't factored something out, a bunny dies. So I'm going to kill one, just one, hoping that I save many, many, many more in the process. Okay. So I'm going to cancel those. Okay, a bunny just died. So I can't do it here because this is not a factor, and things that are factored are multiplied together. This is not multiplied by something, it's added. So that's where we can't cancel it out. We can cancel it when it's multiply. I'm hoping we won't kill many bunnies in this. We'll see. Okay, back to what we were doing. Now what? My other quiet ones. Now what? Oh, well, let me write what we get. Sorry. I feel like I haven't looked at what I'm trying to do for a while. Oh no. Oh no, what happened? Oh no. What happened? Sanjay, what'd you make me do? It's fine. It's fine. I can go off this. Nobody's really volunteering, but I have a list of who needs to be volunteering. It's Tyler, Vivian, Kyle, Abigail, Patrick. You've said something already, haven't you? Okay, I don't want you to give advice, but you can try it on your paper. I mean, on your not paper. Patrick, you got nothing for me? Uh-huh. So you know what you're doing is really good. Let me talk about what he's doing. He's like, I know we don't have much left because if I look at the other side, you're like, well, that's 1 over cosine y, and that is sine y over cosine y. But he doesn't know what to do next to get there. So doing this right now is really helpful. Looking at the other side and kind of thinking backwards. So Abigail?
Couldn't we just separate them from the right now? Like just separate them?
So we can take the denominator and basically, and this might have been what Brandon was saying, distribute that denominator. It's on the bottom. We're distributing it to the numerator. So we'll have 1 over cosine y plus sine y over cosine y. So I'm basically unadding my common denominators there. And then the last step would be secant y plus tangent y. When we get there. So what Patrick did is actually maybe our next, yeah, that's actually what we talk about with our next example. So if you look at the other side, so, like this isn't part of my proof, that's not part of the proof, but that helped me figure out what to do next on the side that I was working on. So this next example was supposed to show you that, but I guess I really don't have to do that anymore because we just saw it. Which side should we work on? Which one's more complicated? The left is more complicated. They both have one addition and division, but with the two terms on the bottom, the left side's more complicated. This is the one that the book was using for looking at both sides. Oh. All right, Kyle and Tyler and Vivian, did she just talk? No, three of you. Who's gonna go first? Tyler.
Cotangent squared theta equals 1 minus cosecant squared theta.
Okay. Now, do you have that memorized? Or are you looking at the list?
I had it memorized at one point, and then I just looked at the list to make sure.
Okay. I can never keep track when it's a minus or a plus. Like, I usually don't use those because I just can't remember them. I guess I could if I really tried, but I can get around using those sometimes.
Remember that like they're both positive on the same side, and then like when you flip it, or when you flip them off,
You're going to have to maybe show me that on paper. I don't know what you're talking about. Because you're saying they're both,
well,
I don't know who
so
they
if,
are.
like, sine and cosine. If you transfer cosine to the other side, then it's going to be negative.
Right, I got that one, but I don't remember the cosecants and the cotangents and the.
But they're both positive on the same side.
Show me later.
Both the terms.
So the very original one is this. So what's the one with cotangent and cosecant look like?
Cotangent plus cosecant is 1.
It isn't, but it's not. That's not it. It's like a minus. But I can figure it out by looking at this one. I could figure it out right now.
But it's 1 plus cotangent.
Right. But if I have cotangent and cosecant on the same side, it's going to be a minus sign. So that's what, like, remember, just pure memorization. I can just never remember it. But like looking at this, I might be able to figure it out. But it's just, that's what I'm talking about. You guys can memorize them if you choose. You can derive all of them from this original one. Or you don't have to go down that path. Sorry, Tyler, that was a very long pause on what you did, which is totally fine. Okay, I'm going to go over the next step. The next step would be to factor this numerator. That is a difference of squares, and the bottom is just one of those. So difference of squares makes conjugates, 1 plus cosecant theta and 1 minus cosecant theta. And because I factored them, if they are factored, you can cancel factors. So now I've got 1 minus cosecant theta. But that's not what I'm trying to get. That's not 1 minus sine theta over sine theta. So here's where maybe looking at this side for a moment might help you. If I had done it with this side, I probably would have done 1 over sine theta minus sine theta over sine theta, which would give me cosecant theta minus 1. Did I do something wrong on the first one? Is it cosecant squared minus 1 and not 1 minus cosecant squared? Tyler, do you know what you did wrong, hon?
What did you say?
Who has their list in front? Like I said, I think Tyler told me it wrong. Like I said, I don't have them memorized. So cotangent is cosecant minus 1, not 1 minus cosecant. Which was my big discussion about why I don't use those so much, because I don't have them memorized, and I couldn't even catch your mistake because I didn't have it memorized. Hey, but you know what? I knew I was doing something wrong at some point. Like I could figure out that I had something wrong. so I can go back and fix it now. And it's okay because it erases. It is not stuck forever on my permanent record, with the exception of it's on the internet, or going to be on the internet forever. But that's okay, I can handle it. Okay, so I actually get I get cosecant minus 1. Okay, so now I need cosecant minus 1 to look like 1 minus sine theta over sine theta. So when I started looking at the other side, which I did in pink off to the side, I can see what I need to do next to get there. What I need to do next is I need to change cosecant into 1 over sine. And I need to change 1 into sine theta over sine theta, which will become 1 minus sine theta over sine theta. And then we're done. Okay. And then example 7, there's 3 examples, but they're examples from calculus. And I think we're going to do these a specific way. Yep, we're going to do these a specific way. There's different ways of doing these. I'm going to purposely do it a specific way. I'm going to box in this side. Well, it says examples from calculus. I'm going to change tangent to the 4th x into tangent squared x multiplied by tangent squared x. Vivian, try something. You can see what we want it to look like. Do you have your identities handy from our notes last time? Okay. Or from the notes in chapter 4? Are there any identities that, I don't know, secant and tangent are related to each other in? So you're super quiet. So you said 1 plus tangent squared equals secant squared theta. So we don't have 1 plus tangent squared. This is what she said. 1 plus tangent squared, oops, theta equals secant squared theta. Is there one that says secant squared theta? Yeah, wait. No. Is there one that says tangent squared theta equals? Or can I just make one right now? If I subtract 1, yeah. So if I know tangent squared theta equals secant squared theta minus 1, oh, this is x. I can just replace one of those. How am I going to make it look like this side? Distribute. That one wasn't that bad. All right, the next one we are going to use, which side? We are going to use, we're going to block that one in. Block that. We're going to use the sine to the 3rd, cosine to the 4th. Gracie.
So for our homework, are we going to have questions like these ones?
No, you get to do them however you want.
Okay.
I'm just going through how you would do it by the harder side.
Okay. I was just confused on how we would know which one to start with for these last ones. Okay.
It's just there's examples and it says 3 examples from calculus, and we are pre-calculus trying to get you ready for calculus, so we're going to do them together. Okay. So for this one, let's see. I know that there's a sine x, but right now there isn't just one sine x. There's multiple sine x's. So maybe separate them. Oops, wrong side. Maybe separate sine x and sine squared x with cosine to the 4th x. Kyle, I need more cosines. I only want one, oops. I only want one sine, but I need more cosines. Can you help me get rid of the sine squared? Right, so sine x is still there. This is going to be 1 minus cosine squared x. And then cosine to the 4th x. Well, if I distribute here, get cosine to the 4th x minus cosine to the 6th x, and then I'm just moving that sine x to the other side. So it looks the same. Done. All right, last one. So I'm going to work with the easier side, which is the harder side. We need cosecant squared when we're done. Right now I have cosecant to the 4th. Who has an idea? Brandon. Okay. Where can I go from there? Anybody? Somebody? Vivian? Change what to 1 plus? This is what you're talking about? Are we sure that's the right? Anyone want to confirm that's correct? Okay. All right, now it looks like, oh, I just need to distribute my cotangents. Oh, and reorder. No, I don't need to reorder them. Never mind. Okay, so that is the end of our notes. I did not do an example like every single possibility that you're going to come across in your homework. Like you're going to have to try, and you're not going to bring an empty blank page up to me and say, I don't know where to start. Okay, so you guys have quite a bit of time. We've got 25 minutes before the first group goes, and then 35 minutes before the second group goes. So you got lots of time to get plenty of these done. It's in the book. It's, where are we at? This one here, page 367, 1 to 55 odd. And if nobody's asking me questions, then I am going to work on it myself.